for extended reality is an umbrella term for virtual reality, mixed reality, and augmented reality. Augmented reality is a technology that displays computer-generated content on top of real-world images. The user is immersed in the real world and gets additional input from AR. A classic example is found in tourism, where mobile applications are used to label and give details about sites pointed at by the phone camera. Virtual reality is a computer simulation in which the user is immersed with one or more senses. While in a VR environment, the user does not perceive the real world. Classic examples are any number of games played with VR-specific gear, such as a head-mounted display. Mixed reality is a technology that combines real and virtual reality by overimposing VR content on top of real-world images in such a way that it blends naturally. MR is a more recent technology and requires specialized hardware that allows the user to perceive both the real world and the virtual environment. Examples of MR applications are found, among other domains, in healthcare where students can learn anatomy by seeing the 3D content overimposed on a human body. XR applications are found in numerous domains of our life, with the market exceeding $25 billion and expected to double in a few years. Of the many domains where XR makes an impact with its technologies, we will discuss healthcare, entertainment, manufacturing, retail, education, defense, tourism, and real estate. XR applications in healthcare allow students to learn anatomy through viewing 3D organs, bones, muscles, etc. overimposed on the body. Immersive simulations of MRI or CT scan data let surgeons and medical teams prepare and rehearse complex interventions. During surgeries, doctors can be kept informed of patient status through XR content displayed next to where the surgeon's focus is directed. XR presence in entertainment is huge due to the massive gaming industry. Besides gaming, immersive storytelling and theater are becoming very popular. In manufacturing, XR can be used by factory planners to analyze the floor plan, processes, and flows for safety and optimization purposes. XR can also be used by workers to get information on the job next to the point of focus, such as providing aircraft assemblers or maintainers with live information about the parts they are working with. For designers, it is valuable to explore life-size models of their parts. In retail, AR is used to provide reviews for items pointed at by the camera. For online retail, trying before buying is a critical aspect of the buyer experience. Providing XR solutions that allow the buyers to better assess the aspect and fitting of their items of interest can reduce the return rate significantly. In education, XR can present an ever-growing amount of information to the students in an intuitive and engaging way that makes it easier to understand and assimilate. Hands-on experiences of the studied subject, be it a fly over a geographical area or a walk through an ecosystem, can make the information more accessible and interesting. Defense combat training is inherently dangerous, but high-quality XR applications allow the trainees to exercise in realistic and safe environments before risking their health in real-world exercises. Moreover, XR simulations are cheaper than the actual field training. Many of the most attractive tourism objectives are inaccessible to the great masses due to either travel costs or health problems. XR can help with this by taking users through a virtual trip to the top of Mount Everest without the massive expenses or health risks due to cold and lack of oxygen. It can also take users to the hot sands of Sahara without the risk of sunburns or dehydration. The goal of this chapter was to introduce the concept of XR and present its domains of applications. The key points are that XR is an umbrella term for AR, VR, and MR, that it is a growing multi-billion-dollar market, and that it brings innovative applications to many domains of our lives.